In this module, we'll create an API using MVC 6. We'll do this by first building an API controller. We'll use verbs for different actions on that controller. We'll use validation in our APIs. I'll introduce you to view model mapping. We'll show you how to create association controllers. And then I'll introduce how to use query strings in your API. Let's start by building that API controller. We're going to start by creating an API controller. Before we get started, you're going to need a tool called Postman. If you go to getpostman.com, you'll see the tool here. It's a free tool that you can use on any of the different operating systems, and it is exposed as a desktop application, or you can also use it as a Chrome extension. I suggest getting the 32 or 64-bit version of the Windows application if you're working on Windows, because that's the version we're going to use. When you run Postman for the first time, you'll see this simple page where you can put in a URL, and I'll do something like wildermuth.com, and hit send, and it'll execute that request and show us what we got back. We'll see there's a 302 found, which is what was returned. We'll see any cookies that were set. We'll also see any headers that were set as well. We're going to be using this to write our individual calls to our API to test them. So back in Visual Studio, we'll also want to open up the project settings while we're working on the API. And under Debug, unclick Launch Browser, because we're going to be executing calls directly to the web server from Postman as a way to really get us comfortable. If you haven't used Postman or tools like that, I think you'll pick it up pretty quickly. So now let's open up that controllers folder, and let's create a new file called products controller. Now for our products controller, this is going to be a controller that we're going to expose API endpoints for. If you've used ASP.NET MVC before, you might remember that Web API was a separate library that you would use to expose your APIs. In ASP.NET Core, it's all one library. So we're going to derive it from controller, just like we did when we were exposing endpoints for views. We're going to do the same base class for when we're going to return data. First thing I want to do is create a constructor, because I want the Dutch repository. And I'll bring in that namespace. And I'll create a field for it, just like we've done before. And I'll do the same thing for iLogger products controller. And I'll create a field for that as well. That way we have both the repository to call and deal with data, as well as the actual logger to show any exceptional cases. But so far we haven't exposed any data through the API yet. What we want to start with is an attribute for route of our controller. Now in this case, we can use an attributed route, just like we could from the views, but we're going to prefix it with an API. Just as the style of the URL, I want all the API calls to be under API/ whatever it is. I'm just using this as a convention. You can design your URLs in any way you want, but I'm going to do just much like I did before, where I'm using the name of the controller here, in case we change it, and then just prefixing with API. That means when we finally implement an action, we can do it in a few different ways, but I'm just going to say IEnumerable product, which is that pure entity, and I'm just going to call the method get. And what you call this method isn't actually that important. I like to call it get because I'm exposing a get verb from my API, and so I need to tell it that I want it to be a get by just including this HTTP get attribute. And this way I can use the repository to, let's say, get all products. And let's see if this actually works. Let's build this for a moment. Let's run it, which is going to start the web server, but it's not going to launch the browser because we turned that off a minute ago. We'll go back to Postman. And let's put in localhost 8888, which is the port of our development project, API products. And we can see, if we look at the pretty version, that we're actually getting all of that data back, just like we got it from the database. So you might think we're done. We have implemented a get, and that's fine. We do have a problem though. If we come back over to our get, let's implement it the way we actually would, which is probably with something like a try catch. And we log this error. But we need to be able to return something. And the problem we have is we could certainly return null. But in the case of returning null, we're going to just get an empty result. We're not going to be able to tell the user what that actual error was. And there's some ways to work around this in that you can force an exception to be thrown that then catches that. But this becomes a problem for writing robust services because we have to go through all this trouble to deal with the other cases we may handle. Whereas by returning the actual product type, we're sort of being given a free ride to the simple implementation. But as soon as we deviate from either returning the collection or nothing, it becomes a lot harder. We can change this to another type of result, which is a JSON result. And in that case, we have to wrap our result in JSON. We can return a JSON result that had some error information in it. And this works, but this does a couple of things I still don't like. One is that the JSON result itself means that we're tying ourselves to always returning JSON. And it may be that as data types change or we want to support different types of data, this becomes pretty rigid and we're not letting the MVC 6 system decide what type of data we can write out. Because in the way that MVC 6 can handle this, they can actually do what's called content negotiation. So as the caller says, hey, I can accept plain text or XML or whatever the new data type is tomorrow, the handshake as the request comes in says, hey, you've given me data and I'm going to serialize it in whatever formats that the caller actually wants. And we want to be able to leverage that. And the trick there is to return action result just like we would when we're returning views. And what this looks like is that we can then wrap our result in OK. Now, OK, that's because we're telling it in the return what status code we want to return. In this case, OK is a 200. It's you're getting the right data, nothing bad is happening. And then down here we can say return bad request, failed to get products, or whatever you want to say in there, or not say in there. But we're able to tie these method calls to actual status codes, like status 200, status 400, even status 500. And when we get into some of the other calls, we'll be able to leverage and use the correct status codes for what we actually want it to do. We're not going to dumb down any of this. We're really writing APIs the way that the web works. We're saying, okay, we're using a get to get in here. And then when we return, we're returning actual status code. So when I read this, I know exactly what's happening. There's nothing under the covers that's sort of hiding that from me. So if we save this, go back to Postman, and let's just send it again. We'll see that from the user's perspective, this hasn't changed whatsoever. They're still going to get JSON, but that's mostly because JSON is the only built-in data type that MVC 6 enables by default. You can go in there and change and add new serializers for different data types you may want. So for most of this course, I'm going to use this same pattern of using iActionResult, using OK, bad requests. I'm going to be using these methods. But you may be building public APIs. And public APIs have the problem of wanting to document them well. And there are some solutions out there, like Swagger is a big one, for looking at an API and then building some documentation from it. And so starting in ASP.NET Core 2.1, they added some support for this idea. One of the reasons why this doesn't become easily documented is iActionResult sort of hides what the real data type that's being returned. While we get the benefit of being able to return good status codes, we are losing that. And so what ASP.NET Core 2.1 added was the ability to change this to an action result that took a data type that is going to be returned. So in our case, of course, get all products returns an IEnumerable of product. So we could put in here IEnumerable product And that would allow our API to sort of define what is actually being returned. In fact, if we change the base class from controller to controller base, we'll be able to normally get rid of the OK in these cases. Essentially, OK is going to try to convert what you're returning here to an OK or a 200 return code for this type. And you see it's still not working because it says it can't convert them. And that's actually because of a problem in C#. Let me see if I can explain this for just a moment. If we change our result type here to just a product, and we tell it to just return our first product, which is this call is going to return just a single product. This works. This would normally be perfect. This reads really like what it's supposed to do. We're going to return some real data, and if something goes bad, we can still use those bad requests. And that works for any concrete types. The problem we have is actually with enumerable. So let me explain what I mean by this. So the action result itself works because they're creating an implicit operator for this data type that we have specified. So it's trying to create an operator that will return one type for another. And that's awesome, except that C# doesn't allow us to convert interface types. In order to do these implicit conversions, they have to be concrete types. They cannot be interfaces. This is just a limitation in C#. And so in these cases, we're still going to need to use the OK. Alternatively, I've seen some solutions out there that talk about using things like lists instead of IEnumerable, where we would have to call something like toList. Not a big fan of having to change what I'm returning into a new collection type in order to support this. I would rather leave the OK there and leave IEnumerable as what I'm actually returning. Again, the idea behind this isn't to make our code that much clearer or concise, but to allow us to run tools against it that will help us document them. In that same way, we can annotate this with an API controller attribute. This is going to tell those sorts of tools what controllers are actually API controllers. We could even help with this documentation by adding another attribute that says produces. This is where we're going to give it our type. And in that case, it's actually going to be application JSON to tell it that this API controller is always going to return application JSON, which is something that most likely for your API it is. This also allows us at the method level to be able to do the same thing. Produces response type to tell it all the different response types that are expected so that the tooling can say, okay, this produces a response type of 200, which of course is okay. And we can add multiple of these to explain what we expect this to produce in normal cases. Now, there's some magic happening underneath the covers here to validate some of this. So now let's look at some more complex ways of getting data with ASP.NET Core. So now let's look at some other scenarios for returning data. In Visual Studio, I'm going to add yet another controller. I'm going to call this orders controller.cs. And like we did before, I'm going to derive from controller. I'm going to create a constructor that both takes a Dutch repository and an iLogger. So enough of that boilerplate. Let's go ahead and add a route for our controller as well. This would be API just like it was before, and we're still going to use the controller name as the route for this controller. And finally, we'll create a get, a bit like we did before. And we'll just return the repository get all orders. But of course, this get all orders isn't actually implemented yet, and we'll implement that in a second. I like to finish out all the error handling before I need it so that I don't forget to put it back in. But on too many projects where we have a task at the end of the project to add logging and add error handling, makes me a little crazy every time. So let's log an error, fail to get orders. And then we'll just return a bad request, failed to get orders. So how are we actually going to implement this get all orders? We want to first make sure that we're returning an OK around our get orders, and then we can go ahead and just implement the method on the interface. Once it's been implemented, if I hit F12, it'll take me to it, and you'll see that its return value is object. Because it couldn't infer what we're actually returning, I'll go ahead and just change that to enumerable order. We have it on the interface, but our underlying class doesn't. So if we open up our data and open up a repository, we'll actually see we're going to get an error here saying does not implement the new get all orders. And so if we hit control period, we can actually just tell it to implement the interface, and it'll add us a boilerplate for that get all orders. That way we can just return context orders, let's say to list for now. It's a good starting point. If we build this and then go back to Postman, we should be able to change this to orders and have it get our new piece of data. Woohoo, we're getting our order. But notice something, the items are null. Now I know that when we created the seeded data, there were items. Why would the items be null here? This comes back to the way the Entity Framework Core works. When we ask for orders, we're only going to get that level of the hierarchy back unless we add include, and include is in a different namespace, Microsoft Entity Framework Core, so we'll need to add that namespace. And include can take a lambda so we can tell it what to include, and in our case it's going to be items. Now that we've included the items, let's rebuild this, and then go back to Postman and let's execute it again. This time it shows that we could not get any response. That means something pretty bad has happened. So let's go back to Visual Studio, and in the output window, there's going to be an option that says ASP.NET Core Web Server. This is the actual web server that is being run with all that logging information. And so what we'll see if we look here is we'll actually see fail and an exception that caused it to crash. Actually caused the entire process to crash. This only causes a crash because we're using developer exception page. There's something about the result that developer exception page can't show. But the important part of this is this line right here, self-referencing loop detected in property order. Self-referencing loop, what does that mean? If we go back and look at our entities for a moment, our order has a collection of order items called items that we were just looking at. But if we look at order items, we have a property called order. What that actually means is that there is a self-referencing loop because the order item refers to the order that refers to the order item that refers to the order, and it gets caught up in a self-referencing loop that it can't resolve. It's trying to take this object graph we have and turn it into a hierarchy inside of JSON, and it just doesn't know what to do. So typically there are two ways to solve this. One is to get rid of the order here, though I find it pretty useful to have it on my order item entity for when I'm working in C#. So what I'm going to do instead is go to Startup. Let's come down here to after we've added the controllers with views and the Razor runtime compilation. And in order to handle the circular reference, we can't just do add JSON options because this hasn't really been fixed in Microsoft's JSON implementation. But what we can do is actually add Newtonsoft JSON, and this is going to allow us to revert into Newtonsoft's JSON.NET implementation, which handles recursion for us. Before we can actually put this in, we're going to need to go and add a package. I'm going to manage NuGet packages, and we're looking for not just Newtonsoft.json, but we're looking for MVC Newtonsoft, specifically Microsoft.ASP.NET Core MVC Newtonsoft JSON. Let's go ahead and install that. And once it's installed, we'll be able to add Newtonsoft JSON as a new option. This means use the Newtonsoft JSON.NET instead of the built-in one. And we're doing that so we can actually configure it. And what are we going to configure it to do? We're going to configure it to set the serializer settings dot reference loop handling. This is a special part of their serializer settings that we can actually set to reference loop handling ignore. Now in our case, because it's a self-referencing loop, ignore is going to just cut it off once it realizes it's a repeated object in the object graph. We could also say, do your best to serialize it, and it'll actually allow you to do this by creating a deeply, deeply nested object, but that's not really useful here. The other would be as soon as it finds it, throw an error, and this is the default behavior. So we're going to say ignore here, and now that we've made that change, Again, serializer settings, reference loop handling to reference loop handling ignore. We can go ahead and run this and see it work. And go back to Postman. We'll see that it happily serialized that JSON for us. Now what it does with ignore is actually just trim off the self-referencing object. So the JSON itself just won't include that because of course it wouldn't make any sense. We still have this product as null, so we could even change this as well. We can do that by going back to the repository, and where we told it to include the items, we could have, I'm going to break this in different lines so we can see it a little better. We could, if we had more than one property, add a separate include. So we could say, oh, whatever the other property was. But because what we actually want to do is include a property inside one of those sub-objects, after the include, I then can say, then include. In that case, it is an order item, and I can just say product. If I rebuild that, go back to Postman and execute it, I actually have the entire order, including all the product information, if I needed that. This could be something I enabled and disabled, and we'll actually see that a little later. Now that we can get the entire collection, let's go ahead and implement being able to get an individual order. So we're going to start with the same action result, and I'm going to call it get, but instead I'm going to accept an ID so that I know which order I want to get. That does mean we need to extend the URL to pass in this ID. And if you remember, on the route we have API and then the name controller up here. So I'm just going to add an argument that can be passed as part of the URL called ID. And in fact, I'm going to use this :int to say what is the data type we expect. There are several primitives here where you can specify what they are. If you don't specify anything, it can also be a string. So I only want it to map here if they've actually given us a number for the ID. I'm going to copy this try-catch from our collection return, and I'm just going to make one small change, and that is we're going to call getOrderById on the repository passing in that ID. But of course, this hasn't been implemented. So we're going to start a pattern that we'll do a number of times here, where we're going to add a new method we need on the repository interface and then implement it in the repository. So I can implement it by just saying generate the method, and then let's navigate over to it. And you notice it wants to return an object because it couldn't infer the return type. But I know that this is supposed to be an order, and I'm going to clean up the interface a little and just put all the orders together, all the products together, and then leave save all here at the end. And then by going into our repository, I'm just going to go to the interface because it's now missing a method, and have it implement the interface. And that means what it's showing over here, it's going to generate a getOrderById that we have to implement. Now to get this, we're going to use the context, and we could say find and then just give it that ID. And that will work in exactly the way you would expect it to. But this makes it a little harder for us to do what we did up here and include the products and the items. So let's copy this query for a minute. And instead of using find, I'm going to add a where clause, where the order.id equals the ID. And this is showing us an error because this toList wants to return a collection. So what we're actually going to do is change this to say first or default. This is going to do this query for us, find the one that's for the ID, and return the first result or a null in our case if it didn't find it. Now because we're searching against the primary key, it's pretty safe that it's going to either return 1 or 0. But first or default is the way we can sort of specify that. Let's go back to the controller. And we now have this OK happening whether we got the order or not. So let's make one small change and retrieve that, but only return OK if order does not equal null. Once we know the order is not null, we can then return the order inside the OK. We're just going to add an else here to say return not found if the order is null. And the reason for that is this ID may not be valid, and so returning not found makes more sense than bad request. Back to Postman. Let's add the order number 1 that we know exists. And we can now see we're getting that order. And the only difference between the two results, with or without the 1 right now, since there's only one order in the database, is that we're not getting that top level array construct. We're always going to be returning one and only one order. But what happens if we give it an order that doesn't exist? Like 2. We get not found so that the caller of the API can figure out the right thing to do. Next, let's learn a way to add new orders to our project. Now let's implement post in our API so we can add new orders. Back in our orders controller, let's create a new method, action result, as usual. This time I'll call it post, and I want to add onto it an HTTP post as the method. So we're not going to change the URL for post because it's going to be differentiated between the URL for this get and our post by that verb. So when you actually execute it, one of the things you send to an API is what verb you're using. And so all posts will come to this method itself. But how do we actually handle a post? Let's put in as a parameter the model that we want. So this is going to be a new piece of data that we're going to send down into the post. And then here we'll add it to the database. And we'll do that in a moment. I'm just going to return OK for now, just as a placeholder. And let's set a breakpoint here so we can construct a request and see how that data is being handed down into the model. Let's create a new tab in Postman so we can go back between the get and the post. And first thing we'll want to do is change that to post. And then we can use the same URL we were using before, but of course, ending with just orders. Back in Visual Studio, if I just launch the application, and in Postman, if I just send it, I'm not going to make any change, just post to that. We'll stop here, but our model exists, but has just default properties. The order number is null, the items are null, the ID is 0, and then the order date is just essentially a null date. That's because it couldn't find any information in the request, and it sent this order in without any data. So back in Postman, let's change this a little. What if we were to add a query string for order date equals 2017-0505? If we look at the model, we'll see that it set that order date, and then we could pass in this data directly from the query string. This mapping of the order data from the query string is actually pretty useful, but we're not going to use it here. Because what we really want to do is be able to structure the body with the data. And the reason the body works more than the query string is the query string is a flat name value pair, whereas the body might actually be a hierarchy of data. We may be passing in the order and the order items and maybe even the products that we want to save to the database, all as one logical unit. And so we need to send the data via the body. And there's a few different ways of doing this. We can tell it that we want as form data, as form URL encoded, but for the most part, because we're going to be mimicking calls from JavaScript or other languages, we're going to probably want JSON as the data type. That means here in the body, we can do things like order, date. And we could specify all the other properties, but it's not actually that necessary. We can send in only the pieces of data that actually matter to us. Let's go ahead and resend this. And now that we've gotten in here, we have our model, but the data never got there. Why is that? The reason is it's assuming that this data is going to come from the query string. What we actually want to do is add an attribute called fromBody to this order. And later on, when we implement yet another controller, you'll see why an attribute on the parameter is the best and easiest way to do that. But now that we have fromBody, let's run it one last time. And over in Postman, let's send it one more time. Here we're getting the model, but it now includes that date, and it would include order number and or ID if we sent those as well. So we're getting correct mapping from the body of the element as a JSON body into our CLR object. So let's get rid of the returning of the OK. Let's actually handle saving this new order we have to the database. So I'm going to start with a try catch, like I usually do, and then just log the error. I like to do this first, even though you've seen me do this a number of times now. That way we don't forget to actually put logging in, so I like to start there. And the first thing we're going to need to do is add our new order to the database, and we can do that with our repository, except our repository doesn't have any place for add entity. So in our case, I'm going to have an add entity that'll allow us to add any type of entity. I could create methods here for add, order, and the other pieces, but it's not really necessary because as you will be able to see, the code we're going to be doing to add the entity is simply to take the data and then attach it to the context so that when we save changes, that those changes, those new objects attached to the repository and the context, more importantly, are then pushed to the database. In the same way that if we get data from the database and modify it, we'll want to allow save all to save those changes as well. So let's implement this by adding it to the interface. Let's navigate to the interface with F12. And instead of order, I'm actually going to accept an object. That way, any entity type will be able to add itself through the repository. And over at the repository, now that we've made that change, let's go ahead and implement the interface. And there's our add entity. We're just going to use the context to add. And we'll see that the API for add actually just takes an object of entity. So we can do it as simple as that. We're just have some plumbing to push it into the context. Back in the controller, what we're going to want to do is we could simply say return OK and pass in the model. And that would work, except that'd be violating the way that HTTP works. In HTTP, when you do a post, the requirement is that if you've created a new object, you actually need to return created. Created is a 201 instead of a 200 that specifies not only that you're going to tell it where on the API it is, but also pass back the data. So we can do that by just crafting a very quick URL. And there are better ways of doing this. I'm going to do this for brevity of just saying API, orders, and then to match our HTTP GET here, I can simply put model.id. Now this is an important idea here because the model likely won't have an ID when it's passed to us because it will never know what the ID in the data store is. But when we call save all, this model that's attached will get that fix up being done by the DB context. So this model ID will actually be the real ID for the object. And that's the reason why we're actually passing this data back, because there might be more fields that are generated by the server that we need to pass back to the client so it knows this is the actual latest version of that object. So if you remember, our save all was actually a Boolean. So let's test that save all. And if it was successfully saved, we'll return created. Otherwise, on the bottom of our method, we'll just say return bad request, failed to save new order. Or however you want to expose error information back to consumers of your API. Let's build it real quick. And then back in Postman, let's now send this once again. And if we look at the result, we'll see that we have created 201 instead of a 200. Here's our new order. Notice that the ID is 2 because that's what the database generated for us. And then we have the other pieces that we really haven't done a lot with. But we're getting back the order that is the most current version instead of trusting the one we sent. Lastly, there's a header put in for us, and that is location. So that we should be able to take this API orders to, put it here, and get only the brand new order. So we know that not only did it return an order, but because we're calling this different API, that it's actually being pulled out from the database. We do have a problem though. When we sent this data to be added to the orders, we can see in the body of the result that order number was null. And so it took on faith what we sent it to it as a valid order. Though in our case, we don't know that. We don't know that this data is actually valid, therefore being able to put it in the database. Let's look at validation and view models next. So now let's talk about using validation and view models in the APIs. If you remember back to earlier in the course, we actually implemented a view model for the contact. So here's our contact view model, and we were using attributes to validate the kind of data. And this is, in fact, exactly what we can do here in the API as well. The same subsystem of model validation exists both in APIs and when you're returning views, because the same subsystem is used for both. The combination of being able to build REST APIs as well as build traditional request to a view type of controller means we can benefit from that same code. So let's start by going and creating a new view model for order. And I'll call it a order view model. And I want this to have essentially the same properties as my order, but I might use different names. Like here for order ID, I'm going to use the full name order ID instead of just ID. I'm also going to have a date time for my order date. I'll leave that as the same name. And then I'll have a string for my order number, which is a human visible number. So I have our order view model, and let's come down here and say, I'm going to make the consumer of this API always generate the order number so that it's something that they can actually consume or figure out how they want to use. So I'm going to add required here. And just like before, we're going to use component model data annotations to get these annotations that are going to allow us to do some validation. In fact, I'm also going to add a min length of 4. No order number that is too small. So the required is just going to say that this has to exist as a non-null string, but min length is going to make sure it's at least a couple of characters long. So how does that impact us in the orders controller? What we can do is change this from order to order view model. And the order view model is going to do that mapping so that here in our code, we can say if model state is valid, just like we did when we were building the contact page, then we can actually do something with this code, right? We can guarantee that this model state is valid. And so back here in the bad request, down here, I'm going to add an else on the is valid so that we'll return bad request, but this time we can pass in the model state, and that way the actual errors that are wrong about the data they sent us will be exposed to them. The problem we have is that now that we have a view model, the entity that we want to actually add here is actually a new order. So we have to go through the trouble of converting the model to the order. So let's get the model date, and order number equals model.order number. ID as model.order ID, in case they actually specified something that we can use. And then let's do a little validation. If the new order.order date equals date time min, which effectively says, did they not specify one, then let's make the new order.order date equal date time now. Right? We're going to override the behavior so that we can actually figure out and set up the order date in case it wasn't specified. Because if you remember, that wasn't a requirement of our view model. Our view model just said the number needs to be required, not the date. So we're going to add the entity here in new order, but then down here we need to make yet another change to convert it from the new order back to the view model. Because if we're going to work with view models, we have to work with them in and out. So let me just create a order view model, and we'll do the reverse. We'll say order ID equals new order.id, order date equals new order date, and then order number, new order number. And then here we can change this to use the VM's ID and return the VM. Of course, we need to change this to order ID because we're using that as different names in each. So if we build this back in Postman, let's first try to just execute this as a new order. What we'll get is a bad request. That's because the order number, the field is required. We're getting that data back as JSON of the problems with the validation. So let's change this. Let's say number this time, and we'll just assign our own number. Send that one, and we get another error. The order number must be a string or array with a minimum length of 4. Oh, okay, now I know what's wrong. We add that 4, and when we send it, we'll get created. We'll get the new order ID, the new order date, which was calculated from the current time on the server, and then we'll get the order number. And so we're able to use that validation to create these objects in exactly the way we want. So this works fine, except there's a lot of tedious code in our post for mapping back and forth. And in fact, our gets are still dealing with the raw data types. That's not good. We should have a way of actually mapping our view models to our entities and back and forth. Let's do that next. So now let me introduce you to AutoMapper. So let's start by going up to the top of the project and just right-click on Dependencies and go to Manage NuGet Packages, because we're going to add a package specifically to use AutoMapper. Now, if we search under Browse, we say AutoMapper. What we really want to do is download AutoMapper Extensions Microsoft Dependency Injection. That will install AutoMapper as well. So let's go ahead and include that one. And now that it's installed, let's open up our startup so we can actually wire this together. We come down to Configure Services. We want to add the ability to inject AutoMapper into our controllers. So I'm going to add a new service here, and I'm going to use a method called add AutoMapper. This is in the namespace AutoMapper, so we're going to let it go ahead and add that using statement. And it's still going to show that it's a problem, and that's because there is no extension method of AutoMapper that takes no parameters. We're going to actually need to specify which assemblies we're looking at. And so the best thing to do, in my opinion, is just say assembly, and we'll need to bring in the reflection namespace, and then we can just say get executing assembly, which is our assembly. Now this is essentially telling AutoMapper to go look for these things called profiles that we'll create soon for all the different mappings that we're going to need. And this allows you to structure them, package them in different ways that you might want to. But you may have all your mappings in a separate shared project. In that case, you'll want to also add to this getting executing assembly the assembly that actually has that third-party assembly. So now that we have AutoMapper, let's go back to our controller and let's inject a third service that we need, and that's going to be called iMapper. And we can add the AutoMapper using statement and just call it mapper and then create a field for it, just like we've done with everything else. So what we'd like to do is use the mapper.map to map from a order to an order view model. And we're just going to wrap that order in that. And what this is going to do is it's going to take an order that you pass in and return a mapped version of the view model, because we always want to be returning view models. Let's see if that works. Back in Postman, if we run this, we'll actually get a bad request. Now, why did that happen? If we come back to Visual Studio, let's open the output window, and you'll see one of the options here is the ASP.NET Core web server. And if we look at this near the bottom, we'll actually see that we have a failure here in the orders controller, and it says failed to get orders, which was the message we put in, but the exception was missing type map configuration. It was trying to map from an order to an order view model, which was the code we just did, but it couldn't find instructions for how to map between them. What we're going to see here is when we said add AutoMapper, we specified the executing assembly, this assembly. And the reason we did that was it's looking for any classes that derive from AutoMapper's profile class. This is a set of rules for doing those mappings, and we're missing them because it didn't find any profiles. So the trick here is to come over to data, and I'm going to add a new file called Dutch mapping profile.cs. And here I'm going to derive from profile, which is inside the AutoMapper namespace. Profile is just a container around any mappings that you want to set up. I'm creating one for my whole project, but you could segment them into different kinds of objects so you can decide which of these profiles to use at runtime. I'm going to create a constructor And then just in the constructor, I'm going to create the maps by calling create map. Create map takes two types. So I'm going to say, let's create a map between order, which I'll need the namespace for, and order view model, which I'll also need the namespace for. So I've created a map between these, and it's convention based in that it's going to look at the properties between them and try to match property to property, type to type. Let's go back to Postman and see if we can get this to work now. This is now returning our view model for us. So this is working, sort of. It's not working in that we're not getting the order ID mapped. We're getting a 0, even though it's clearly 2 here. And that's because it couldn't figure out the difference between the ID in order and the order ID in the view model. So inside creating the map, it exposes a fluent syntax that we can use to set up exceptions. This first line is going to do everything it can, but when you know more than the map can infer, you can make these changes. So I'm going to say for member, and I'm going to use a lambda expression to choose the member. So for order ID, I'm actually going to use another lambda to specify what to do, and that's going to be map from, and I can put the string of the property name, but more likely I'm going to pass in a lambda for the source. And so I'm effectively telling it, when you're looking for order ID, map it from the source of ID. If we go back to Postman and try this one more time, we'll see that the order ID is now being mapped correctly. We can use the same mapping in our orders controller for our collection as well. So let's just map our new orders. First, I'm going to get the result just so it can be a little clear, and then I'm going to use that mapper. What I can tell the map to do is to map to a certain type. Now the map takes as generic parameters 2 pieces. It can take an order and an order view model, and you'll notice here in the IntelliSense it says the source and the destination. And then of course if we put result here, it's going to complain because this is an IEnumerable. One of the other interesting things is that you can avoid this first parameter because it can infer it from here. And so often you'll just say map to the destination type and then include the type here. Of course, we have a mismatch between returning a single model type and returning an array type, which is why it had shown an error. So we're going to want to tell it that it's a collection. And if we just put IEnumerable there around this, it will actually take this collection of order and try to map it to a collection of order view model. Now this can be any kinds of collection. We could make this a list, an I collection, or even just a simple array. As long as it is something that it knows how to convert into, and those are all common collection types that it can deal with. For us, we're going to leave it as IEnumerable, because we've defined what we're returning here in the action result. We're going to convert by using the maps that we created from an IEnumerable collection of orders to an IEnumerable collection of order view models through the mapping. Back in Postman, if we've done this right, should be able to just call orders and get all the orders in the database now. Here's the one we started with, and then the 2 that we actually created. So back in Visual Studio, let's see how we can use mapping here in the post to make this simpler. So what we really want to do is, instead of doing this, this is effectively the same thing the mapper does. So instead, let's just use the mapper here to convert the view model we're coming into an order. So this will do the opposite map, and we're going to pass in that model. We still may want to do these exceptional cases, and then we're going to save this new order, and instead of mapping it back, we can now just do the same here. We can say new order. Now the trick here is interesting, because one thing to note is that we're using the map in opposite directions. This map is order view model to order, and this is order to order view model. So let's see if this works. Go to Postman and add yet another one. We're going to get another bad request. In Visual Studio, if we look at the output again for the web server, we'll see we're getting another missing type exception, but this time it's in the order view model to order direction instead of order to order view model. In fact, if we go up a little, or quite a lot, we'll actually see the old error was order to order view model. So how do we solve that? If we go back to the profile, at the end of this exception, again, it's a fluent syntax, we can say reverse map. That just says take all of the information you have here about creating the map and create one in the opposite order. So not only does it create a map for order view model to order, but it also takes this member mapping and reverses it for us. Back in Postman, if we now try to add the new order, we can see we're getting a brand new order and all the mapping worked. Getting a new ID because it's a new object. We're getting it back as a view model, even though it was stored in the database. We know that because we can come over here and send to get all the orders again, and our brand new 2002 is right here. Let's see how all this applies to order items as well next. So now let's talk about creating what I call association controllers as it's related to order items. So one of the things that we saw in Postman is that it's cutting off the collection of items when we're returning data. And that's because our order view model doesn't have a property for the collection. So if I add an iCollection for order items, that would do it, but we probably need that same view model idea as we do for order. So let's go ahead and just generate a class. And then let's open up our entity for order item. And let's just copy these real quick. And we'll come back to the product. And because the view models are going to be hierarchical, I don't need the order there at all. And I could just leave these as ID, quantity, and unit price. And we should be good, at least as a starting point. When we validate it against these, we're definitely going to want required for quantity and required for unit price. Now that we have that, we should be able to get the items as part of this view model. But that does mean that we're going to have to come down here and create a brand new map from order item to order item view model. And let's make sure we reverse that so we can use it in both cases. So far, we're not doing anything special about needing to map or make an exception like we did for order ID versus ID. We're just going to leave it right here, mostly to make it a little quicker. By adding this, we've added the mapping profile and we've added the view model to our project. We don't need to tell the order controller when we return data to worry about the order item view models because they're already included in the mapping of the order when it's set up. Let me show you what I mean. If we come over here to Postman, let's go back to that first order. We're now going to get the same information from the view model, but now we have that items, which is a collection of the different order items that were related to it. But if we go and get the items for another order, the items will just be empty because there are no order items for this particular order. So we do have to set up the map between the different types, but AutoMapper will walk down that collection and try to map everything the best way it can. And what's interesting here is built in it has these mappings between primitive types, but all you're doing by creating maps is creating mapping between complex types as well. If we're going to have the items here, it might be an awful experience to have to add and even iterate through these items by always getting the entire order. So let's create something called an association controller. When I'm designing an API, what I really want to do is be able to look at the different collections at different levels. So what I'd like to do is be able to have an URL that says, go get me the items for this particular order. Of course, that's going to return file not found because there is no mapping for this. So let's create that. I'm going to create a new controller called order items controller. And some of this is boilerplate. I'll try to go through it as quickly as possible. But we first want to derive from controller and then create a constructor that is going to give me a .repository and a logger for order items controller. To add that namespace. I like to put these in different lines so it's a little easier to see, and I'll just call it logger, create a field for that. And then finally IMapper, use the using statement, then create the field. Now for setting up our route here for our whole controller, to define this, we're going to say API like we have before, but here instead of looking for the order items as part of the API, we're actually going to say orders/order ID, which will be the ID of the actual order, and then items. So we're constructing that everything in here is a sub-controller of orders, essentially. So this is going to allow us to walk down the tree via the URL as we want to use the API. So if we do our simple get here, where we want to get all of the order items for this particular property, we're going to need a parameter that we're going to use on each and every call here, and that is order ID. This order ID is mapped here because it's here as a parameter in our URL. In this case, we could create a new repository call for getting the items, but for me, I'm actually just going to say order equals repository get by ID, pass in that order ID. If not, order doesn't equal null, then I'm just going to return okay order.items. Right? I'm just going to go and get that collection of data and return it back. But in fact, what I'm going to do is use the mapper, of course, to map from I enumerable order item to I enumerable of order item view model. So let's bring in that namespace for entities. Let's bring in that namespace for view models. Otherwise, we'll just return not found. So the real magic here is here, where we're mapping the items to the individual call. So let's go to Postman and let's see if this works now. And we're getting a collection, and the fact that there's only one item here is sort of a side effect. Let's create one more get, and we're going to use this as HTTP get again. But because our route on the controller says we need an order ID, we'll continue doing that, but we'll add another piece, and that is the order item ID. That actually comes from an extension of it by just saying ID. And let's change this to the name ID, because it is mapping them by name in this case. And so this is effectively the way to get an individual item by its ID. And we're asking them to pass in both pieces of information. Let's just copy this down for a minute. And the only difference here is if we have the order, let's move this up a little so it's a little easier to see, is I'm just going to say the item is going to be the order.items, where the item ID equals the ID that we were requesting. This sort of guarantees that we're looking for an ID within a context of an order. We might want a whole different controller or different methods here that can get the order item specifically by ID. But in this case, we're asking for both because we really want the API to represent that we're looking at the relationship between the entities. And if item doesn't equal null, then we can return OK, but this time we're going to map between item and just the item in that case. Now, the exact way you generate or you build the logic behind here isn't what I'm trying to teach you. I'm trying to teach you the bigger picture of how you deal with mapping as well as constructing your URLs to have relationships between them. So let's build this. And then in Postman, let's actually add the /1. So this API is implying that we want the first order and then the item with number 1 in that order. So here we're getting just that individual object. Back in Visual Studio, you're going to want to use the same techniques, though I'm not going to necessarily show them to you here on video, to go ahead and create methods for post and delete in order to allow you to add new items, delete items, or even update items. I do have a course on Pluralsight that walks through this in more depth, and you can see the URL to that on the bottom. We do have one other thing we want to talk about as it relates to mapping, and this is a good place to see this. If we look at the way we're getting data from the repository, if you remember when we get an order by ID, we're getting not only the items, but also the product information for each of those items. So we'd really like to have a way to map those. We could go to the profile after adding members and map each one of them individually. But there's actually a convention in AutoMapper that's very convenient if you can live with it. Otherwise, you'll have to write exceptions for mapping them. But let's go to our order item view model, and let's add a few more properties here. So the first I'm going to add is an integer for product ID. And I'm going to make this required as well. So when we eventually want to be able to add these items in, we're going to make sure that the product ID is actually specified so that we know if they give us quantity, unit price, and product ID, we'll be able to store that in. But we might, when we're returning data, want to be able to show this product information. And so at first you might go to the product entity and go, I'm going to want a few of these. Probably don't want all of them, but let me copy them over here. And what we're talking about is really flattening the products into this view model. You could go the step further like we have with order items and create a product view model. But in a lot of cases, especially when it's fairly read-only, this is the right way to handle it. And let's say we want category, size, title, and artist. Probably live without the rest of these. If we prefix these with the word that is the same name as the entity that they're referring to, so product, 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 by making that change, let's build this, and sending this, we'll see that it's read down that tree conventionally. We didn't even need to add product to the mapper. It's using those names to infer that we want possibly the name of a sub-object. So here we're able to get the product ID, the category, the size, the title, and the artist, all which might be useful in actually showing this information on the screen. In fact, to go back here and add one more that I know we'll need later, which is the product art ID. We need this because that's how we're constructing image links to be able to show this on items, and we'll need that later. So now we've made that change. Send one last time and see whether we're getting all the information. There's our art ID that we can use later, and we should be good. We're able to use these conventions that AutoMapper has to get the right pieces of information. Even though this isn't exactly the data that is being stored in the database, it's going to allow us to do some collapsing to simplify the data structures we have on the server versus what we expose through the API. Let's take a look at how to use query strings in your APIs next. So now let's see how we can use query strings in APIs. One of the interesting ideas here is that our URLs can be used to describe what sort of resources we're looking for. I like to use query strings to change the behavior of what it returns in some cases. So the case we're actually going to use here is if we go ahead and execute API orders, we're going to always get that item information. But if all we need to do is show a simple list of orders for a customer, for example, retrieving all this data for the items, including the product information, might just be loading the type of information you need. You might want an option to be able to say include items equals false. So a way to send in an option to trim this down so that the items aren't actually part of the result. How do we do that? Back in Visual Studio, let's go to our orders controller that we have here, and let's add a parameter that says bool include items equals true. So what we're saying is if this parameter isn't included, go ahead and say it's true by default. That way it's making it an optional parameter, which is the nature of query strings. So when I'm using query strings, I'm almost always setting a default value so that I don't have to include it in every case. If I didn't have the equals true, I could have two different methods, one that had the include items and one that didn't for the different behaviors. But I find doing it in the same one makes a lot more sense. So let's refactor this a little. And I'm going to create an object called results that I'm going to use here for mapping. And I'm just going to call repository get all orders. But I'm going to actually pass through the include. So I'm going to go change the API in the repository to now require a Boolean include items. and then back in the repository as well, and you need to do the same change. And this will allow me here to just make that change. If include items, return what we're including. Otherwise, we'll just take off the includes and return a simple list without the items. And again, there might be more graceful ways to write this code, but I want this to be very clear what we're trying to accomplish. Back in Postman, let's make sure the regular call to order still works and it looks good. But if we then add that optional include items equals false, if we turn that off, then we're now getting a very brief version of it. And so changing the nature of what's returned, not necessarily anything that's required should be in the query string, but it does give you the opportunity to be able to add data to help you figure out exactly what the API wants by using query strings. Let's wrap up this module. So what have we learned so far? I talked about API and view controllers really being the same kind of controllers. They take routes and convert them into some output. Sometimes that's data through an API, sometimes that's HTML or markup in the case of a view. What it's doing at the core is pretty similar. I've also shown you that mapping those URIs is simpler if you do it at the controller than trying to have these magic route tables inside your startup.cs that are going to handle every situation. Finally, I introduced the idea of REST verbs to allow you to differentiate the different kinds of operations you want to do, using gets to retrieve data, using post to create data, using put to update data, and delete to delete data. Up next, I'm going to introduce you to ASP.NET Core Identity as a way to log in your users.